Next.js is currently one of the most popular and intelligent web frameworks, but many developers using Next.js often can't fully utilize its superpowers simply because some of its advanced concepts are hard to understand. In today's video, we will dive into one such advanced concept in Next.js called streaming. Technically, this is a feature from React.js, but when used correctly with Next.js, it can massively improve the user experience of any web application. After watching this video, you will have no more confusion about streaming. You will be able to implement a super smooth user experience on your own website. And your app, it will feel blazing fast, perform like a champ. So without any further ado, let's get started. Let's kick things off with a simple example. What you are seeing on the screen is a basic Next.js app. On the home page, we have a heading that says Next.js Streaming, and below that, there's a button linked to a page called Streaming Demo. Now, notice what happens when I click the Streaming Demo button. I have clicked it, but the page takes a bit of time to load. And honestly, the user experience here is terrible because from a normal user's point of view, it's not clear whether the click even worked. So, what's causing this delay in loading the page? Well, it's because the cards on that page are being loaded dynamically. We will look at the code shortly and it will make more sense. But this loading process is happening asynchronously. And since everything in the page is being rendered on the server, which as we know happens inside the app component in Next.js, it's being rendered as a server component. Let's take a look at the code now. If we open the page.js file for the home page, there's really not much there. It's a simple page with just an h1 tag showing Next.js streaming and a button that says Streaming Demo. That demo button is linking to the page inside the Streaming Demo folder, right? If we look at the page.js file for that root, we will see it's using a component called tools card. Inside the tools card component, tools are fetched using a function called getTools. And if we go into that function, getTools, you will see it's a server action. It maps over an array called tools. If you check that tools array, it's just a simple strings of array, names of different tools like JavaScript, React, Vue, etc. While mapping through that tools array, each tool string is passed into a function called generateToolsData. This function takes two parameters, the tool name and a delay. We have set this delay to 3000, meaning 3000 milliseconds or 3 seconds. Now, if we open up the generateToolsData function, we will see its main goal is to simulate a fake delay. It uses setTimeout and multiplies it with a random number and our predefined delay value. So each item experiences a slightly different delay. To simulate the delay, we are using a promise and awaiting it to maintain asynchronous behavior. Because of this, the tools.map function is returning an array of promises. Since this is an async function, it naturally returns promises. Now, back in the tools-card.js file, we will see that we are getting an array of promises from getTools. Then, we are passing that array to promise.all, which resolves all the promises together. Finally, we get back an array of strings, one for each tool, but each one had a delay before resolving. So, we just simulated a loading delay using async setTimeout. But in real life, this delay could come from fetching data from a database, a network request, or hitting an external API server. Basically, any async operation that takes time, we have just simulated that behavior. Now, using the tools with data array, we are running a map again. And for each tool, which is just a string, we are rendering an icon card component. The tool name is passed as a prop into icon card. Icon card is just a simple presentational component that renders a card. We are using the card component from the ShadCN library, nothing too fancy. Inside the icon card, you will see a card header showing the tool name, a like button beside it, which is its own separate component, and in the card content area below, there's an icon rendered by another presentational icon component. Now, if you check the code for the icon component, you will see it has an array of SVG icons. Using the find method, it selects the appropriate icon and renders it. Inside the icon-card.js file, there's another component called like button. If you open the code for this button, you will notice it starts with the use client directive because this button handles client-side interaction. It has an on-click event attached. So when you click it, a love sign appears. That interaction is happening entirely on the client side. That's why we had to define it as a client component. Inside the component, we are using a simple useState hook with like and setLike function. When the button is clicked, we toggle the like state. If it's true, it becomes false and vice versa. There's some conditional CSS too. If like is true, the button turns red. If not, it stays gray. Very simple interface. Now we have got two main problems here. First, when I click the streaming demo button from the homepage, I experience a poor user experience. After clicking, I have to sit and wait because the page is taking time to load. The second problem, this one's called a false interaction. Imagine this. While I am on this page, I reload it and click on a card to give it a love reaction. But when the page finishes loading, that love reaction is gone. That means we just had a false interaction, and that can confuse a normal user. Why? Because technically the page rehydrated and replaced everything, and the interaction didn't persist. That's exactly what we mean by a false interaction, and this is happening because of server-side rendering. This is one of those UX downsides of SSR. Let me break it down. When someone hits this page, the request first goes to the server. Then all the async operations begin. I will call that phase A. Once that's done, the HTML gets generated. We will call that phase B. Then the HTML and CSS reach the browser. Let's call that C. And finally, once the JS bundle fully loads in the browser, we reach the hydration phase. Now, if these terms like page rendering and hydration aren't clear to you, I recently made a full video covering Next.js rendering and caching. It's a must-watch for any Next.js, React, or general web developer. You will learn how your web page is rendered, how hydration works, and how the whole rendering process is coordinated between browser and server. Everything will become crystal clear to you. So make sure you watch that video if any of this feels confusing. I have left the link in the description. If you are watching on YouTube, you might have already seen the card pop-up. Back to the main point. We now understand that server-side rendering involves server blocking tasks, meaning while data is being fetched, nothing else moves forward. Until that's done, the page can't render, and if the page isn't rendered, nothing reaches the browser. And without that, hydration can't begin. These steps can't run concurrently. They have to happen one after the other. That's why we are seeing this issue. Let's say our page has 9 cards. Maybe some cards could have loaded earlier, but the full page waits until all 9 are ready. Result, we see everything at once at the very end. Wouldn't it be great if we could improve that user experience? That's where streaming comes in. A few moments ago, you saw the whole UI load at once. From the outside, it looked like all the components rendered together. But in reality, each part of your page is rendered separately. Because in React, everything is component-based, right? Now, what if component A finishes early? Wouldn't it be amazing if we could just send component A to the browser right away? Meanwhile, component B, C, etc. are still processing, and once ready, they stream in next. That's exactly what we call streaming. Server-side rendering is definitely faster than client-side rendering, but the real problem with SSR is the user experience. That's why we use streaming. Think of it like YouTube. When you play a video, does it download fully before starting? Of course not. The video plays immediately, and the rest keeps loading in chunks. That's buffering. As a user, you don't feel any lag. It's a super smooth experience. We want the same experience on our web pages, and that's what streaming is all about. As you can see on the screen now, the sidebar section of the UI is already loaded, but the right side content is still in a loading state. This is exactly the kind of experience we want to build. where parts of the page load independently as soon as they're ready. And this is definitely better than traditional SSR because it gives users a much smoother experience. Now, here's something important. Streaming only works with server components. To implement this, React gives us a tool called React Suspense. We will now use React Suspense to upgrade our current demo and see how we can take this streaming experience to the next level. Let me bring you back to the code again. The first thing I'm going to do is, remember that demo I showed you earlier? That's our starting code, right? I have saved that exact starter code in the starter branch of the GitHub repository. You will find the repo link in the description. So, from the starter branch, you will get the exact code we are starting with. Now, to implement streaming, I will start with Next.js default streaming system. There are two ways to do streaming in Next.js. The default or automatic streaming, where you don't really have to configure anything, just follow a simple convention. The custom or advanced streaming is the second one, where you manually set things up. I will first show you the automatic streaming demo. Then I will walk you through how custom streaming works. Each approach will live in its own separate branch. The primary starter code stays in the starter branch. Now I am creating a new branch. I will call it automatic streaming for the automatic streaming demo. All the code changes I make from now will go into this automatic branch. The very first thing I will do is, inside the streaming-demo folder, I will create a loading.js file. Inside that, we will return regular JSX like in any standard React page. But instead of just showing plain text like loading, we will take the modern approach and build a skeleton UI. That means we will mimic the same structure of our actual cards. But instead of real content, we will show placeholder skeletons. So users will see something shaped exactly like the real card, but it will be in a loading state. And when the real data comes in, it will replace the placeholder in that exact same spot. That's how we will build the skeleton UI, just like modern web apps do for better user experience. Let's now implement the same kind of loading skeletons that modern apps use. To do that, I will follow the same structure used in the actual cards on this page. If we go to the home component, you will see that everything starts from tools card, right? There's a wrapper div. We will need that as the outer container. So first I'm copying that container div from the home component and pasting it into the loading.js file. That's our outer wrapper. Got it? Then there are two nested divs inside tools card. We will need these two. I will copy both of them and paste them as children inside the outer wrapper in loading.js file. I will also make sure to close any missing end tags properly. That's it. The full structure is ready. Now we need to insert 9 cards inside this layout. To understand what each card should look like, let's open up the icon-card.js file. You will notice each card is just an icon card, right? So we will use that same structure to build our loading skeletons. To save time in the video, I have already built a card skeleton component in the components folder named card-skeleton.jsx. Inside that component, I am using the skeleton component from ShatCN. Pretty straightforward. On the UI, we have 9 cards in total. So I will render 9 of these skeleton cards. How? Inside loading.js, I will use array.from. I will pass length to 9 to create a blank array of 9 elements. Then I will use map on it. Since we don't need the actual array, I will skip with an underscore. And to set a key for each element, I will grab the index as the second parameter. For each interaction, I will return a card skeleton component with the corresponding key. And that's it. Our skeleton-based loading component is ready. Now let's reload the homepage. Notice the loading experience is already in action. No more issues with false interactions. Meaning you can't click the like button while it's loading anymore, because the actual UI hasn't rendered yet. So in reality, we didn't do much. We just created a loading.js file inside the streaming demo folder, and that alone triggered automatic streaming in Next.js. How? Let's take a look. Remember what we did? We created a loading.js file, right? Because of this file structure, behind the scenes, Next.js automatically wraps our page component with a React suspense boundary. The page component is wrapped in suspense on both sides. And the fallback used there is our custom loading component. This whole wrapping is done automatically by Next.js. We could have done it manually by explicitly writing the suspense component and its fallback, and that would have worked too. But we didn't have to because we are using Next.js, a smart framework. Next.js is basically saying you don't have to do all the heavy lifting, just place a loading.js file in the folder, I will handle the rest for you. And internally, it wraps our page with a suspense boundary. That's how automatic streaming gets applied. And this gave us a much smoother user experience. Wherever a part of the page is ready, it gets shown immediately. However, take a closer look. The whole page is still appearing together. Until then, we just see skeletons as the fallback for everything. That's definitely an upgrade compared to the previous version, but it could still be better. Why? Because the cards on the page, they don't all take the same time to render. Maybe the JavaScript card resolves quickly, but the Vue.js card takes the longest. And the delay caused by the Vue.js card is affecting the visibility of even the JavaScript card because all the cards are shown together. Wouldn't it be better if we had individual card level rendering control? How can we do that? Simple. If we wrap each card in its own suspense boundary, we'll get that experience. But before jumping in, let's analyze the actual issues here. Right now, what's happening is card 1 completes step A, B, C, and D. Then card 2 starts, then card 3. Basically, cards are loading serially. But what we want is each card should be in its own suspense boundary, so they can load concurrently. Whichever one finishes first should appear immediately. And that's exactly what we are going to implement next. We will change the code and see exactly what modifications are needed to make this work beautifully. Back in the code now. Before we implement this advanced feature, let's commit the current state of our code to GitHub so you can experiment and tweak it yourself. In the terminal, let's write git add dot git commit -m for message and let's say automatic streaming. Done. You will now find the code under the automatic branch in the GitHub repo. Now let's move on to learning custom streaming. For that, I am creating a new branch. Git checkout -b for branch custom-streaming. Our new branch custom-streaming is ready. Let's start our Next.js dev server again. Since we are now going to stream manually, I will delete the loading.js file. So that default streaming fallback with the card skeletons, that's gone now. Next, let's open the tools-card.js file. Here, we are calling the getTools function, which returns an array of promises. Earlier, we used promise.all to resolve all of them at once. But this time, we don't need to do that anymore. Why? Because we are going to wrap each icon card component with its own suspense boundary. That means React Suspense will handle the promise resolution for each card individually. So here's what we will do. First, card the icon card component. We will reuse it shortly. Then, instead of tools with data, which is the resolved array we got using promise.all, we will now directly loop over the tools array, which contains the unresolved promises. So we can remove the tools with data logic entirely. Now in our JSX, we will replace the old toolswithdata.map with tools.map. Previously, each item in the loop was a resolved string called tool. But now, since we are dealing with unresolved promises, let's rename that variable to toolPromise. We will also grab the second argument index. So we can use it as a key. Now, in the return statement of the map function, we will return a suspense component for each interaction. Inside each suspense, we will render a child component called toolCard. We haven't created the toolCard component yet, but we will do that in just a moment. We will pass toolPromise as a prop to the toolCard component. So what's happening here? Tools is an array of promises. We are mapping over that array. On each iteration, we get a tool promise and an index. Since tool promise takes time to resolve, we are wrapping it inside a suspense boundary. Inside the suspense, we rendered the tool card component. And we pass tool promise as a prop to it. Simple. Hope this part is clear now. Now we will go ahead and create the tool card component. But before that, we need to set a fallback inside the suspense component. The fallback means as long as the child component inside suspense hasn't finished resolving its promises, this fallback UI will be shown instead. So we are using card skeleton as our fallback component. That means until the promise is resolved, users will see the card skeleton component. Also, we need to set a key for each item. And here we are using the index as the key. Alright, now let's create the tool card component. We will define it in the same file just outside of the tool card component. Let's write const toolcard equal to function. Inside the function, we will receive tool promise as a prop. Now, we will use React's modern use hook to resolve the promises. We will pass tool promise into use and it will return the resolved data. We will store that in a variable called tool. Then we will return some JSX. Remember the icon card component we cut out earlier? We will simply return that here. So return icon card. And we will pass the resolve tool as a prop into icon card. Alright, let's take a moment to clearly understand what we just did. Previously, we used to take the array of promises returned from the getTools function and resolve them all at once using promise.all. Once after all of them were resolved, we would render the components. But now, we are not using promise.all anymore. Instead, we are leveraging React's suspense. We are working directly with the array of promises. Each promise is being passed into the toolcard component individually. And when that specific promise resolves, the toolcard then displays the corresponding icon card. Until it's resolved, we show the card skeleton as the fallback inside suspense. Super simple. Now let's check the terminal real quick, just to see if there are any errors. No, looks good. No errors. Now, if we head over to the browser and from the home page, click on the streaming demo button, look at that. All the icons are streaming in one by one. As soon as something is ready, it appears. It's no longer waiting for everything to resolve at once. Whichever item resolves first, it streams directly onto the page. Here's another cool thing. Let's say you reload the page. Now, one of the cards appears early and you give it a love reaction. See? No problem at all. Even after all the other cards load, your love reaction stays intact. Why? Because the card you interacted with has already been hydrated. Clear? So that old confusing behavior where a user would interact too early and the action would disappear, yeah, that's no longer an issue. With just a small change, we now have a complete streaming experience. If you want to stream at the page level, just use a loading.js file. That way, the whole page shows a loading state covering the entire area. But if you want to stream things individually, like different components or sections, you can simply wrap them in separate suspense boundaries and handle it your own way. That's streaming in Next.js terms, or more simply, in React's language. Now, one final point I want to mention. Remember how I kept saying server-side rendering, server-side rendering. But here's the funny part. If I run npm run build right now and build the app, this streaming demo page will actually become a statically rendered page. Why? Because there's nothing dynamic going on here. So according to Next.js rendering logic, this becomes an SSG or static site generation page. Right? If you are not familiar with SSG or SSR, please do check out the video I recommended earlier. It explains everything clearly. And for those of you who are familiar, you know that if we build this page, it becomes a static page. Which means SSR doesn't really apply here because the page is already pre-generated at build time. When the user requests it, it won't go through get data, get tools or any promise-based fetch because everything is already pre-rendered and baked into the build. Now, if this page were a true server-side rendered page, then streaming would make a lot more logical sense. So how can we force that? Easy. At the top of the page.js file, just add this line. Export constant dynamic is equal to force-dynamic. That tells Next.js, hey, treat this page as dynamic, no matter what. Clear? Now, whether you build the page or run it in dev mode, the page will always be treated as a dynamically rendered page, meaning it will only be rendered on the server when the user makes a request. And that's when streaming truly becomes meaningful. So now, if we run npm start and open the same site again, you will see the exact same streaming experience, even in production mode. I hope I was able to explain clearly what streaming is and how it works. It's honestly a very simple concept, and I really hope you now understand how and where this can be useful in your own projects. If you found this video helpful, please don't forget to like, comment, and share it with your developer friends. It really helps support the channel and reach more people like you. Thanks a lot for watching all the way till the end. I truly appreciate it. I will see you in the next one.